Thank you very much for giving me the floor. I would like to thank Mr. Balakakis for this invitation to attend this very important event. I would also like to thank Mr. Kittas for his presentation, but I'm afraid that after such a meticulous presentation, what can I say? How can I compete his presentation? Anyway, I would like to thank him because he's the former director of the lab, of which I am the director today. I'm talking about the Laboratory of Agricultural Constructions and Environmental Control. He has been the professor with whom I have worked for many, many years. He is the pioneer who paved the way so that myself and my team find ourselves here today talking about the greenhouses. Thank you so much. Well, Mr. Kittas has said it all about greenhouses, so I'm going to say a few words and I will show you some pictures and videos. I would like to present you the greenhouse park that we have developed at the University of Thessaly. And on this occasion, I would like to say that we are here to show those who are interested some innovations and some things that can be implemented as of tomorrow in their production. I would also like to say a few things about the rationale of circular economy, where we try not to emit anything at all and to use everything that is generated in the greenhouses or everything that is generated in the form of waste at the end of the farming process or other production processes. This is what we try to integrate in the greenhouse park of the University of Thessaly. Can you please turn the sound on?
Εδώ είναι λοιπόν το θερμοκηπιακό πάρκο του Πανεπιστημίου Θεσσαλίας, το
Greenhouse Park of the University of Thessaly at Velestino estate. Those are greenhouses that have been built over the past years, and of course we also have simple greenhouses. This is a greenhouse park where various research programs are being carried out and implemented, everything on the basis of circular economy. So, in some of the research programs that are running in the greenhouse, we use the various applications of hydroponic farming in order to see their impact on the farming. So, we use the inflows that come from the effluents of other uses, other holdings, other crops, and this is how we can save on water. These crops are hydroponic crops. Here you can see the main crop that we have. It's a crop of tomato. You can see various substrates. We try to see how we can better manage the climate conditions in the environment of the greenhouse. We try to ensure the conditions and see what we can do in terms of the irrigation and fertilizers of the crops, in collaboration with numerous research organizations from Greece and abroad, in collaboration with companies that focus on how we can save on energy, water, fertilizers, in order to offer producers and farmers new tools, new knowledge that they can benefit from. And we also have other projects that have to do with aquaponics, meaning the water that is used in this farming is also used in aquaponics. The fish can offer us fertilizer that is useful for our plants. We have numerous students working there, and thanks to their contribution we can implement all those programs. And I would like to continue by presenting a few innovative actions that are being implemented there. They're open to the public. This is why we try to host various events at least twice a year, but due to the pandemic we know that's more difficult. However, we host open days so that people can visit and see what's happening. I believe that you have got a glimpse of the first part, and I must say that in hydroponic farming 30% of the water that is irrigated and includes fertilizers is effluent of the crop. And it also includes a substantial amount of fertilizers that we have given. If we let that go, if we dispose that, we miss a substantial part of the fertilizers we have used. So it is on the basis of this rationale of the management of those effluents we developed a program where we're collaborating with another university from Germany and 2 companies from Greece and Germany, and we developed a system where whatever is drained from the one crop is used as an influent to another crop that is more resilient in terms of salinization when we have water of poor quality. And this is how we were able to develop additional crops in the greenhouse without using water or fertilizers. All those things are in an experimental phase. We have seen them, they're available. There's no point in giving you numbers in terms of what we have achieved. All these things are included in the newsletters that we sent in the context of our activity at the university. The next topic we're working on currently and will be available for production, or it will be available after 5 years, because this is when we'll be able to share our results. And those are things that it's worth implementing after a few years, once we have all the evidence and data that can support the viability and sustainability. I'm talking, of course, about aquaponics, where we combine fish cultures and crops farming. So we take the water that needs to be renewed. It includes the feces of the fish, it includes nitrogen, and this is a fertilizer for the plants. So we use that in order for us to grow our crops, and we reduce the use of water and fertilizers in our greenhouses. And all that are being tested in various simulations, and the greenhouse projects we run. And always on the basis of software that we develop for those things. Some more figures, there's no point in giving you more information about that. Another topic we're working on is the growing of microalgae, which can be used, apart from their numerous uses, for fish feed. So we take everything, all the wastes with glycerol from their production, and everything that is generated as a waste from biogas production, and this lays the foundation for us to develop and grow microalgae that we use in order to feed the fish in the tanks. And the last program that has just started, it's a program that incorporates numerous technologies, and we try to present them in practical application. Robots for the management and spraying of the crops, so when insects enter specific traps, so that we can study all those systems. I'm talking about the insect populations that enter the greenhouse, various systems that help us develop and achieve better decision making, and of course microalgae production on the basis of the waste generated. I think that I'm okay in terms of time, and allow me to add the following. With this presentation, I wanted to remind you that we are here. We have a technological innovation park at the University of Thessaly. We are always open to collaborations with farmers and businesses that want to test and to study new things that they consider worth studying or considering. We are here to help you find the solutions that can help you tomorrow in order to better develop your production and capitalize on your